good afternoon, good evening. It's your boy Mr. Malachi, and welcome to this video where we're going to be consolidating factorization. This is for grade 10s. So what are we going to go through in the video? We're going to do highest common factor, how to factorize using highest common factor. We're going to look at common bracket factorization. We're going to look at grouping. We're then going to look at difference of two squares. That's what dots means. And then we're going to do trinomials, and then we're going to end off with the sum and difference of cubes. So I hope you guys stay tuned and you enjoy the video. So let's jump right into it. All right, so let's start with this type of question. It's a highest common factor. We do need to find the highest common factor and take it out. So the rule I always do is I always check the numbers separately. So a 4, a 8, and a 12. What number goes into all three of those numbers and is the biggest number that goes into all of them? So yes, 2 goes into all three, but 4 is the biggest number that goes through all three of those numbers. Then I have a P, I have a P, and I have a P squared. I also have this rule that says if you're looking at variables, the highest common factor of variables will always be the variable with the lowest exponent. So we have a P that has an exponent of 1, a P that has an exponent of 1, and a P that has an exponent of 2. So clearly the P with an exponent of 1 is the one with the lowest exponent. So we're going to take that one out. And then between the Q's, we have a Q2, a Q, and a Q. So definitely using the same rule, a Q would go out because that is the lowest exponent. Then I ask, a 4PQ needs to multiply with what to give me back to this 4PQ squared. So it seems that we have everything. The only thing that is missing is a Q, because a Q times another Q would give me back to the Q squared. So 4PQ times what would give me an 8PQ. So it has to be a negative, and a 4 times a 2 would give me that 8PQ. And then lastly, 4PQ times what would give me a negative 12P squared with the Q. So it has to be a minus 3, and since we have one P there, we need to add another P there. And that's it. This is my final answer. All right, hope that makes sense. Let's look at the next one. What if we have a 16 a to the power 4 b to the 8 that is being subtracted by an 8 a to the 3 b to the 7 that is being added by a 36 a to the 2 with a b to the 3. Again, looking at just the numbers, a 16, 8, and a 36. Which number goes into all three of them? So yes, a 2 goes into all three of them, but a 4 also goes into all three of them, and the 4 is the biggest number that goes into all three of them. So I take out the 4. Between the A's, I have an A4, A3, and an A2. Remember what the rule is. You always take out the one with the lowest exponent. I have a B8, a B7, and a B3. So a B3 would come out as my common factor. Then I open this bracket and I ask the same questions again. This 4a squared b to the power 3 needs to multiply with what in this bracket here to give me back to the 16 a to the 4 b to the 8. So 4 needs to multiply with the 4. A squared needs to multiply with another a squared to give me an a to the 4. A b to the 3 needs to multiply with a b to the 5 to give me back to a b to the 8. So that's how you get the first term in the bracket. The second term, 4 multiplies with the 2 to give me an 8. A to the 2 multiplies with just one a to give me an a to the 3. b to the 3 multiplies with the b to the 4 to give me a b to the 7, right? And then lastly, this 4a squared b to the 3 multiplies with what to give me this guy. I notice the a squared is already in the answer. The b3 is already in my answer. So the only thing that needs to multiply there is the 4 that needs to multiply with the 9 to give me this correct answer there. So this is all that I'll be doing in terms of highest common factor. It was just a consolidation lesson, remember? So let's move on to common bracket. So I call this other type of factorization the common bracket factorization. And why do I call it a common bracket? You will see just now. So what if we given this that is being subtracted by this? So I call it a common bracket because instead of taking out a common factor, we notice that there's a bracket there that is the same. So again, I will take out that bracket that is the same. I'll write it in front. Sorry, this is a Q. And then I open my other bracket and I ask, if that bracket is gone there, what was left outside that was multiplying it? It's the 3a. And if that bracket is gone there, what is left outside that was multiplying it is the negative 2b. And this is your final answer. So these common bracket ones are quite easy. As long as you can see a bracket that is the same, you can easily do this. Now let's look at what would happen if the bracket was not exactly the same. Then we are introduced to this other new concept of switcheroo. And I'll tell you more about what that concept does. So we're going to apply switcheroo for this question. Switcheroo. And what that means is, since these brackets are not exactly the same, we notice in the first bracket the x is positive, the y is negative, but in the second bracket the y is positive, the x is negative. So instead I'm going to switch the second bracket, and if I switch the guys in the second bracket, so what do I mean by switch? I mean I'm just going to change the position of these guys. I'm going to keep that minus, change the position of those guys. But if I do that, one fundamental thing needs to happen. The sign outside needs to change. So if the sign outside changes, it becomes a negative. And inside of my bracket, I will have the x that is being subtracted by the y. So I hope you guys can see how switcheroo works. And now that the brackets are the same, I could just easily take out the common bracket, which is the x minus y. And again, if it's gone there, what was left multiplying it? It's the 2a squared. If it's gone there, what was left that was multiplying it? It's the minus b. And there we go. Very easy. Let's do another one last question on common bracket. What if the common bracket looks like this? X minus y to the power of 2 x minus y to the power of 3. So this kind of follows the same logic as a common factor. And you're sitting there thinking, how? So let me first do a common factor example that is similar to that. So instead of having this whole bracket, let me put an x in place of that whole bracket. And if I just replace the second bracket with an x as well. So if this was your question and you were asked to factorize this, then you were going to notice that, ooh, I have x to the power of 2 and then x to the power of 3. So I always take out the smallest one. Then you open your bracket. It needs to multiply with the 1 to give me x squared. And on this side, it needs to multiply with the 4ax. So this is how you were going to solve it if it was looking like this. So if it's common bracket, we apply the same thing. So we're going to take out this bracket, which is y minus x, or x minus y squared. Then we're going to open another bracket. Then we ask if that x squared, x minus y squared, if that's gone there, what was left that was multiplying it? It's this 1 that is in front. So I put a 1 there. If this one is gone, but not all of it, 2 of it is gone. So now I'm left with at least 1. So it should be a 4a with the same bracket, but to the power of 1. You don't have to write that 1. You can write it if you want to, but you don't have to write it out. So this is the answer I'm getting. I hope it makes sense. I've shown you how it actually looks when it's common factor, and I've shown you how it actually looks when it's common bracket. The logic is the same. It's just that now you're working with a bracket for this question. All right, so that concludes everything that you kind of need to know on common brackets. Let's move on to this other one, which is called grouping. And this type of factorization is implicit in the name. The name kind of implies exactly what we need to do. So let's take an example. Ax squared minus x plus a 2ax a squared minus a 2a. So we have this question and we are asked to factorize it. So what grouping says, it says look at your expression, find the things that have a common factor. So I see in this two terms, the first two terms, there's a common factor of x that I can take out there. Already I know I can see that. And these next two terms, I notice that there's a 2a that I can take out as a common factor. So let's group them in that case, in that way. So I'm going to group the first two terms, put it in brackets, put a plus outside, and I'm going to group the second two brackets, or the second two terms. All right. Then now that I've grouped them, I take out my common factor. In this case, it's an x. So the x goes outside of that bracket, and I'm left with this, right? And in the second one, if I take out the 2a as my common factor, and then I'm left with just ax there minus a 1. Then 9 times out of 10, your common bracket should be popping up. You guys noticing that? This is a common bracket and this is a common bracket. So if that pops up, then you should know that you're doing the right thing. So I take out my common bracket, which is ax minus 1. I write it first. Then I say if it's gone there, what was left that was multiplying it, it's the x. If it's gone there, what was left that was multiplying it, it's the 2a. And that's my final answer. All right, so at this point, take a deep breath, rationalize what's happening here, and make sure that you understand everything. You can pause the video if you want to, you can rewind if you want to, and yeah, the whole point is to make sure that you understand what is happening. All right, let's take this next one. It is also a grouping type question. At the end, I'm going to unpack how do you know which is which, and given a question that says just factorize, it doesn't tell you, how do you differentiate whether I need to do HCF, whether I need to do trinomials, whether I need to do sum and difference of cubes. I'm going to unpack that a little bit later in the video, but right now let's just keep doing grouping on these type of questions. All right, so what I notice here again is that the first two terms have a common factor, and that common factor is a 2x. So I'll just note it up there and I'll come back and I'll take it out. And these next two terms also have a common factor, which is 2m. So let me group those. Let me group the first two terms together, put them in a bracket. That's what grouping means. You just put it in a bracket. I'm going to leave a negative outside, but watch this. If the negative is outside, the 2mx needs to be positive inside of the bracket. Why? Because negative times that positive would give me back to this negative at the top. So I'm using that whole logic. So the 2mx needs to be positive in the bracket. The next one needs to also be positive in the bracket. Why? Because a negative times a positive would give me back to the negative at the top. Remember your integers. So that's what I'm applying there. So I can take out my common factor in the first bracket, which is a 2x. I'm left with an x plus a p, right? And in the second bracket, if I take out a 2m, I'm left with the same x plus a p. And like I said in the previous question, the common bracket should always pop up. If it's not popping up, then you grouped the wrong terms. You need to go back up in your question and try grouping another set of terms. All right. So in this case, I take out my common bracket, which is an x plus a p. And in the next bracket, I put my 2x with my 2m. And there we go. This is how you would factorize this question up here. Right? Let's do, I think we're good in terms of grouping for now. Let us move on to the other type of factorization, which is difference of two squares, dots. So dot stands for difference of two squares. And these are quite easy. These are my favorite because these are relatively easy compared to every other thing. So why do they call it difference of two squares? They call it difference of two squares because we're always going to have a square there that is subtracting another square there. So that's why it's called difference of two squares. That's one way you can try and rationalize or try and identify these. So now let's factorize it. How do you factorize a difference of two squares? I always just open two pairs of brackets like that. I take my first term, which is a 16x squared. I square rooted. If you square root that guy, it's just like square rooting the 16 by itself, you get a 4. And it's just like square rooting the x squared by itself, you get an x. So now I need to put the 4 and the x together, and that's my first term in both brackets. Did you guys follow that? All I did was square root the first term, square rooted the 16 separately, and I square rooted the x squared separately. Then now I need to square root the second term. The second term, fortunately, is just one number. So if you square root a 25, you actually just get 5. Let me just put the 4x here. So if you get 5, that 5 goes there and it goes there. Then one bracket is positive, then one bracket is negative. And there we go. That is the answer of that guy. So these are quite easy, but sometimes they could get a little bit complicated in that you get something like this. So this is another difference of two squares. As long as this exponent of any variable is an even number, then it's a difference of two squares. And by the way, 1 is also a perfect square. So if I do my brackets there, I open my two sets of brackets, I square root the x to the 4. If I square root an x to the 4, the square root there, the 2 is dividing the 4, the exponent of 4. So I end up getting an x to the 2. So again, the 4 is being divided by the 2, and that's how I get the x to the power of 2. So I put my x to the power of 2 in the first position of both brackets. Then if I square root of 1, I just get a 1, and that 1 goes in the second position of both brackets. 1 will be positive and 1 is negative. And so you're sitting there and you're wondering, Mr. Malachi, what is so different about this question? This question is so different because this guy is another difference of 2 squares that pops up in your answer. So we can't leave it like this because this is not factorized fully. Instead, we need to further break down this difference of 2 squares. We keep the sum of 2 squares because we can't factorize that. A sum of 2 squares cannot be factorized. But this difference of 2 squares, I again open another 2 brackets like that. And I undergo the same procedure. I take the x squared, I square root it, I get x. I put that x there, and I put that x there. The square root of 1, we've already discussed it, is a 1. I put the 1 there, I put the 1 there. 1 is positive and 1 is negative. And this is therefore your final answer. You're probably sitting there like, oh, but Mr. Malachi, isn't this a difference of 2 squares? No, it's not, because the x is not a square. This is not a square. So I put square there with a cross, meaning it is not a square. But if it was a square and the 1 is definitely a square and they're subtracting, then you're going to do another difference of 2 squares down there as well. All right, I hope this makes sense. Let's move on to the next one. Let's do another type of question. Let's do another difference of 2 squares. One where it's also slightly different from the ones that we've seen so far. Let's take 1 to the 8 minus a 5. All right. So you're looking at this and you're like, but Mr. Malachi, this is not a difference of 2 squares. And at first glance, you're right. It is not a difference of 2 squares. But rather, we see a common factor. So let's apply common factor first. So I take out my 5. I'm left with x to the 8 minus a 1 there. So I've done common factor. And now I should be able to clearly see that now this guy is a square. As long as it has an even number there, it's a square. That is subtracting 1, which is also a square. So now I have a difference of 2 squares. I keep the 5 that I've taken out, that I've factored out outside. And I do my difference of 2 squares. If you're square rooting an x to the 8, remember the 2 is dividing the 8 and I get an x to the 4. So that x to the 4 goes there and an x to the 4 goes there. If you square root a 1, you get a 1. I put a 1 there, a 1 there. 1 is positive and 1 is negative. Please don't put both of them as positive and don't put both of them as negative. 1 needs to be positive, 1 needs to be negative. Where you put the negative, where you put the positive, it does not really matter, but they have to be positives and 1 being negative. And then at this point, I don't know, if you guys are screaming, you should be screaming, you should be excited, you should be seeing the other difference of 2 squares that pops up here. So this is a square and this is a square, and since there's a minus between it, it's another difference of 2 squares. So I need to factorize this guy further. I keep my 5. I keep my sum of 2 squares. Again, that cannot be factorized, so you keep it. Then I do this guy. Square root of x to the 4 is an x to the 2. X to the 2 there. X to the 2 there. Square root of 1 is a 1 there, a 1 there. 1 is positive and 1 is negative. Are we done, guys? No, we are not. we need to do another difference of two squares. That last bracket there is another difference of two squares. So I keep every other thing that is sums of squares and every other thing that I've factored out so far. And for this guy, I'll open another additional two brackets. Square rooting an x squared is an x. So this is an x, this is an x. Square rooting a 1 is a 1. 1 and a 1. 1 is positive and 1 is negative. So this long expression that you see below is actually the answer to this small little difference of two squares that you see above. So this is what's fascinating about math, is that you could get something small and just by looking at it you could assume, oh, the answer should be clear and very straightforward, but then that thing blows up into this big answer that you should be getting, and this question is a good example of that. All right, I think this concludes difference of two squares, or maybe let me do one more. Let me do one more where the brackets are squared. So what about something like this? Let me use black. X minus a, the bracket is squared, is being subtracted by a 16c squared. So this, I would advise you to be able to see it as a difference of two squares. So the bracket is squared and the 16 is a perfect square. The c is it's a square as well. So this is a difference of two squares, and the logic of you solving it does not change. Whether you put brackets there, whether you put fractions there, the logic does not change. And by now you should have been seeing the logic. So I'll open these big square brackets instead. And what do? I just square root that bracket then. If I square root that bracket, I will get the contents inside of the bracket. So I get an x minus an a that goes in the first position of both brackets. If I square root the 16c squared, remember, square root the 16 by itself, you get a 4. Square root the c squared by itself, you get a c. Put them together, it's a 4c. And one bracket is positive and one bracket is negative. And this is my final answer. So, like I said, the procedure is what I'm trying to get you guys to understand. The numbers might change. I might put fractions in there. I might even introduce integers in, not integers, but decimals in there. I might do all these nice things to kind of deter you from what the logic is. And the logic is you always square root the first guy, you square root the second guy. One bracket will have positive, one bracket will have a negative. All right, on that note, let us move on into trinomials. So I know I said difference of two squares were my favorite, but I like trinomials as well. And what do I like about trinomials is because we get 3 different types of trinomials. Easy ones, we're going to look at intermediate ones, and we're going to look at the complex ones. And in each of these, we solve them differently. And let me look at the easy one first. So let's take an easy trinomial like an x to the power of 2 minus a 5x plus a 6. Yeah, let's take something like this. So this is a trinomial. And why do we call them trinomials? We call them trinomials because the word trinomial means this is an expression that has 3 terms. That's what trinomial means. It's just an expression that has 3 terms. So each time you see 3 terms, Your brain should be making light bulbs there, telling you, compelling you to apply the trinomial factorization method on that question. So let's apply it. What does it say? You open your two brackets, right? You square root your first term. I'm going to square root the x squared. I get an x. That x goes in the first position of both brackets. Then you look for factors of 6. So factors of 6 are two numbers that multiply to give me a 6. These two numbers are supposed to multiply to give me a 6. But which ones am I looking for particularly, because there's a lot of factors that multiply to give me a 6. A 1 and a 6, a 2 and a 3, a -1 and a -6, a -2 and a -3. So we have like what? 4 list of factors that could possibly be there. But which ones am I looking for specifically? I'm looking for the ones that are going to add to give me a -5. So I'm looking for the factors of this last term that are going to add to give me the middle coefficient that you see there. So my brain is already telling me that I need a -2 to add with the -3 to give me a -5. And does a -2 and a -3 multiply to give me a 6? Yes, it does. So those are the factors I was looking for. I put the -2 there and I put a -3 there. And this is my final answer. So again, I hope you guys followed that. Remember, you square root the first term to get the x, and that x goes in the first position of both brackets. You look for factors of the last term, the constant term. This is your constant. So your constant term is the one we need factors of. And which particular factors are we looking for? We're looking for the ones that add to give me this middle coefficient. So that's the procedure of solving these easy trinomials. So this was an easy trinomial. Let's look at an intermediate one. So an intermediate one kind of looks like an easy one, but the only difference, actually, I will write it first, and you guys, the audience, the people watching this video, you tell me, what is significantly different between this type of trinomial and this type of trinomial? I'll give you a moment to think about that. What is significantly different? So what you should be saying, or what you should be noticing, is that this one had a coefficient of 1 there. The x squared there had a coefficient of 1. And maybe if I did more examples, you're going to see that the more of these easy ones that I do, they always have a 1 there. We don't write the 1, but we know it's there. These ones flip on you and they put a coefficient there. And with these ones, what we need to do is we need to do common factor first. So you'll notice that these factorizations, they overlap every single time. So we do common factor first. And the common factor that I can take out is, I notice there's a 2 there, there's a 24 there, there's a 70 there. So I know that 2 goes into all 3 of those. So I'll open my brackets. 2 times an a squared would give me back to a 2a squared. 2 times a -12a would give me back to a -24a. And a 2 times a 35 would give me back to the 70. Now when I get to this point, then what you should notice is happening is that this guy is going back to looking like an easy trinomial. So what does that mean? We solve it like an easy trinomial. We keep the 2 that is outside. We open our 2 brackets. Square root the a squared. I keep doing this for your favor, guys, for your benefit. for you to see that every single time I square root something to the power of 2 or something to the power of 4 or something to the power of 6, I'm dividing that exponent by 2. So I get an A, that A goes there and it goes there. Then I need the factors of 35. But which factors am I looking for? So I'm looking for two numbers that multiply to give me 35, but they need to add to give me this negative 12 there. So 35, I'm thinking 5 and a 7. Yes, it's definitely 5 and a 7, but you need to make sure the signs are correct. The 7 needs to be negative, and the 5 needs to be negative. Why? Because a negative times a negative will give me back to a positive 35, but a negative 7 plus a negative 5 gives me a negative 12. So these are the factors I'm looking for. I put the negative 7 there, I put the negative 5 in there, and this is your final answer. Please do not forget this guy that is in front. He is utterly important to be part of your answer. All right, let's do the complex ones. So the complex ones are slightly different from the intermediate and the easy ones. And let's have a look at the complex ones. What about 8a squared minus 2a minus a 1? So this looks like an intermediate trinomial. Why? Because this guy, there's a number there. But is it an intermediate trinomial? No, it's not. Why isn't it an intermediate trinomial? Because we cannot take out a common factor. So what is different between the complex ones and the intermediate ones? The intermediate, you can always, it looks like this, just like the complex ones, but you can always take out a common factor. These ones, it looks like the intermediate ones. The complex ones look exactly like the intermediate ones, but you cannot take out a common factor. So what do? Do you panic? Do you run around? Do you give up? No. What you do is you just take that 8 and you multiply it across to the 1. And what I'm doing right now is not mathematically correct. It actually changes the value of the expression. So maybe let me not put the equal to there, because I just changed the value of that expression. But it helps me get to the answer. So the 8 goes away from there, right? I'm just left with the a squared with the minus 2a in the middle. But what is 8 times a negative 1? That is a negative 8. So this is the new trinomial that I get. And again, this is an easy try. What do I mean by an easy try? You just apply the same rules of solving an easy trinomial. I open my two brackets. I square root the a squared. I get an a. I look for the factors of negative 8. This time it's factors of negative 8. So one of them has to be positive and one of them has to be negative. And what do they need to add up to? They need to add up to a negative 2. So what factors am I thinking about? I'm thinking about 1 and an 8. No. 1 and an 8 does not add to give me a 2. Even if I put the negative on the 8 or put the negative on the 1. But what does is a negative 4 with a positive 2. So that is very important. Let me just put my A's in there first. And so the first bracket would have a minus 4 there. And the second bracket would have a positive 2. So I've factorized it like this. And at this point, you're not done. There's still a little bit more steps that you need to do there. And let me show you what the steps are. Let me just erase this, guys. Alright, so just as much as you multiplied with the 8 in the beginning, you need to come and make this expression the same again. And what am I going to do? I'm going to divide those factors with an 8. Divide by 8 there. and I divide by 8 there. And at this point, I can bring back my equal to signs. And the first fraction simplifies to be a 1 over 2. The second fraction simplifies to be a 1 over 4. But in trinomials, we never want to see these fractions. We never want to work with these fractions. They just look just weird. And so what we do is you take this 2 and you times it across to the a. You take this 4, you times it across to the a. And if you do that, it ends up being a 2a minus 1. The numerator of 1 is still there. And this ends up being a 4a with a positive 1. And there we go. There we go, grade 10s. This is how you do your trinomials. So at this point, I know I've only done one of each, but I do want to keep this video under an hour. So I'm going to move on to the sum and difference of cubes. And this is the finale. This is the last things we're going to be doing. Sum and the difference of cubes. So this guy is similar to dots, difference of cubes, difference of squares. It's similar to that, but this one specifically refers to cubes. And let me take an example. Let's take an x to the power 3 that is being added with 1,000. And again, you're asked to factorize this. What do? A sum of cubes, you open two brackets. One needs to be slightly bigger than the other. Excuse me. It needs to be slightly bigger than the other one. And what do? I take this first term, I cube root it. So with the difference of two squares, I'm square rooting, but this one I need to cube root that first term. And if I cube root it, I get an x. That x goes only in the first position of the first bracket. Then I take the next term, which is the 1,000, and I cube root the 1,000. And if you cube root 1,000, you should be getting 10. That goes in the second position of the first bracket, just the first bracket, right? Again, what did I do? I just took the first term and I cube rooted it. I got an x. That goes there. I took the second term, I cube rooted it, I got a 10, and that goes there. So how do you get these guys here? The first term of the second bracket, you take the first term of the first bracket and you square that term. So if I square an x here on the side, if I square an x, I end up just getting an x squared. The last term of the second bracket is also found by squaring that second term. If I square 10, I get 100. The second bracket has 3 terms there, so there's one more term missing there in the middle. How do I get that? I times the x with the 10. So the guys that I have in my first bracket, I just multiply those guys. So what is an x times a 10? It's just a 10x. So the 10x goes there. So now I have everything. I just need to decide on my signs. If this is a sum of 2 cubes, then this bracket will get a positive. This will be negative, and this is always positive. Whether you're doing sum or you're doing difference, this is always going to be a positive sign. Alright, so this is my final answer. So take it in, pause the video, copy down what I have there, and maybe write it in words. Write it in words to actually see what does sir mean when he says square. What does sir mean when he says square there? How did sir get these terms right there? And how did sir get this middle term here? So maybe write it out in English, in words, so you can actually remember it. Let's do a difference of cubes. what about if we have an a to the 6 minus a 27b to the 12? So again, how do I know that these are cubes? As long as those exponents are divisible by 3, then yes, it's a cube. And this 27 is also a perfect cubed, so maybe it might help you to know your perfect cubes as well. There's there's 1 to the power of 3 is 1. There's 2 to the power of 3, which is 8. 3 to the power of 3, which is 27. 4 to the power of 3, which is 64. 5 to the power of 3, which is 125. So if you list all those guys and you learn them, and after using them after a while, it becomes second nature, you know? All right, so how do we solve this? Again, the process is the same as that I explained in the previous question. So what do? We take this guy and we cube root the a to the 6th. Again, what did I say that 3 is doing to the exponent? What did I say it's doing? It's dividing. Yes, it is dividing. So if 6 divides a 3, or rather 3 divides into a 6, you get an a to the 2. So this is an a to the 2, and you just put it in the first position of the first bracket. How do I get the second term there in the first bracket? I cube root the 27 by itself, I get a 3. I cube root the b to the 12 by itself, and again 12 divided by 3, I get a 4. So this is actually 3b to the 4. I hope that makes sense. Again, how do I find these first and last term here? Remember, you square, so you take this guy, you square him to get this guy. And if you square an a squared, you get an a to the 4. If you square a 3b to the 4, you get a 9b to the 8. Maybe let me show you how that happens. The 3b to the 4 is being squared. It squares the 3 and it squares the b. So I get a 9b to the 8. That exponent there, the 4 and the 2 are multiplying. All right. Then how do I get the middle guy there? I take that first term and I take that second term and I multiply them. So a squared times a 3b to the 4. I'll get a 3a squared b to the 4. And that's this guy that goes there. Right? And now I need to decide on the signs. So like I said, in the previous question, it was a plus there. So you put a plus here. But in this question, it's a minus there. So you put a minus here. This would therefore be a plus. And this is always a plus. This is always a plus. And there we go. I hope this makes sense. Should we do one more? Should we do one more? All right, I'm hearing a lot of yeses. So, a great chance. Please don't think I'm crazy. I'm just trying to make this video a little bit more interactive. So if I'm saying I'm hearing yeses, I'm not crazy. I legit am just trying to make this video a little bit more interactive. Let's do this one. It says 8a to the 4 minus a 27 a b to the 3. Maybe let me change this into like another number we've not looked at. 27 we've done. Let's do maybe 729. Yeah, let's work with this guy. So if I tell you that this is a difference of 2 cubes, would you believe me? No, you shouldn't, because the a to the 4 is not a cube. Remember, the exponent needs to be divisible by 3. So the fact that we have a 4 there and suddenly we have a 1 there, the a to the 1, tells us that this is not really a difference of cubes. But yes, it is. Yes, it is. All it needs you to do is to first take out a common factor. So let's do that. Let's first take out a common factor. So common factor is one of those factorizations that pops up everywhere. It pops up in difference of two squares. It pops up in sum and difference of cubes. It pops up in factorization. It pops up almost everywhere. So it's something that you need to be really good at. So how are we going to take out our common factor? I noticed that a is the common factor. So this is 8 to the 3 minus 729 b to the 3. Again, I've done common factor already, so you should be able to see why am I getting the stuff that I'm getting inside of the bracket. Then at this point, I want to do the difference of cubes. So I'm open my two brackets. One needs to be slightly bigger. And I cube root this guy. Let me do it up here. 8 cube rooted is just a 2. The cube root of a to the 3 is an 8. So this is a 2a. Let me do the other one. 729 cube rooted is a 9. If I cube root a b to the 3, I get a b. So this is a 9b. Alright, then I take that 2a, I square him, and I get a 4a squared there. I take that 9b, I square him, I get an 81b squared there. And again, how did I say we get this middle term? Pause the video, do it yourself, see if you know. But that middle term is found by multiplying the 2a, the first term, and the second term in the first bracket. So if you multiply those, you get an 18ab, and now the 18ab goes there. And now you just need to decide on your sign. If this is negative, this will be negative, this will be positive, and this will be positive. So again, I hope you followed there. Let's do one more. Just one last question. Let's add some pizzazz to it. Let's add something interesting there. Let's do 343. Let me write it in black. 343 is being divided by an x to the power of 6. That is being subtracted by a 64 that is being divided by a z to the 9. So this does not require us to do common factor first. We can jump straight right into it. We open our two brackets. If you cube root this big first term there, you are cube rooting the numerator separately, 343, giving you a 7, and you are cube rooting the denominator separately, which gives you an x squared. So this is a 7x squared. The same with the second guy there. The cube root of 64 is 4. And lastly, the cube root of z to the 9 is z to the 3. So this is actually 4z to the 3. I take this guy, I square him to get this guy, which is a 49x to the 4. I take this guy and I square him to get this last guy, which is a 16z to the 6. The middle guy is a 7x squared that is multiplying a 4z to the 3. 4 times the 7 is a 28. X squared with the z to the 3. So this is a 28 x squared with a z to the 3. Now I just need to decide on my sign. This will be negative. This is positive. This is always positive. Wait. Oh, I did this incorrectly. Alright, let me just rewind for a bit. I'm supposed to be dividing those guys, not multiplying them. So I'm doing the right process. It's just that I'm not writing it correctly. So let's recap, guys. So you're doing these separately, right? The 7, you cube rooted it, you got the 7, you cube rooted the bottom, you got an x squared. So how it should look here, the 7 should be at the top, the x squared should be at the bottom. I hope while I was doing that, you guys were screaming at the screen and thinking, what's going on? Like, why is he doing the wrong thing? Like, at least you should have been able to see that I'm not doing the correct thing. So I'm gonna just do these again. I get a z to the 3. So the 4 is at the top and the bottom is the z to the 3. They need to correspond, obviously. If those guys were multiplying, you put them alongside each other. But in this case, they're dividing, so I put them underneath each other. I take this, I square him, I still get the 49 at the top. Excuse me. But at the bottom, I get the x to the power 4. I take this, I square him, I get the 16 at the top. And at the bottom, I get the z to the power of 6. Right? Then this middle guy is the z, it's the 7x squared that is multiplying the 4z to the 3. The 4 and the 7 gives me a 28 as the numerator. And then the variables just stay in the denominator. So this is a 28 over x squared z to the 3. And then lastly, this is minus, this is positive, and this is positive. And on that note, that's it from my side. Maybe just to give you a final hint on how do you identify these and how do you go about solving it. So first thing you need to do whenever you have a factorization question is to always first check for a common factor. This is what your brain should be doing. Check for a common factor every single time. So no matter how the thingy looks, if it looks like a trinomial with 3 terms, if it looks like a difference of 2 squares, no matter how it looks, you always need to check for a common factor. All right? Then if it does not have a common factor, and if it has 2 terms, if you get something that has 2 terms, then if it has 2 terms, it could either be a dots, a difference of 2 squares, or it could be the sum slash diff of cubes. So it could either be one of those two. You just need to decide. If the first term is a square, the second term is a square, then and there's a minus between it, then it's this guy, a difference of 2 squares, right? If the first term is a cube, the second term is a cube, and there's a addition in between it, then it's this guy, right? So yeah, that's the next thing you need to do when you're looking at a factorization. Just your brain should be going through these. Then if you see 3 terms there, then your brain should be telling you that this is definitely a trinomial. So whenever you see 3 terms, it is always 90% of the time always going to be a trinomial, right? And then lastly, what if we see 4 terms there? So 4 terms, and maybe let me put 6 there. I like putting a grouping that has 6 terms as well. Then this would be a grouping. And that's it, guys. So again, let me just recap. What do you do first? You always check if there's a common factor that you can take out, right? If there isn't, then you go and check. Is there two terms? Yes, there is. Is it a difference of two squares? Is there a minus between them? Is the first one a square? Is the second one a square? Right? Is it a sum of two cubes? Is the first one a cube? Is the second one a cube? And is there addition between them? Right? If there's three terms, then it's almost always a trinomial. You're gonna obviously have to go through the easy one, the intermediate one, and the complex one. You check which one it is from those three, right? Then lastly, if it has 4 or 6 terms, it is going to be a grouping. Then one last thing I did not include is obviously if it has a common bracket there, if it has brackets, if you see brackets, then it's most probably a common bracket. If you see the same bracket, let me put the bracket being the same. And that's it. Yeah. So yeah, let me stop the video here, but I hope this makes sense to you. I hope you watched it. I hope you gained something from it. And on that note, it's your boy Mr. Malachi, and I'll see you on the next video. Goodbye.